Okay, so hi students. Seems like all have joined, and then yeah, we can start the lesson for today. And the ones who were absent can watch the recording of this. So today I'm expecting to start the lesson changes in matter because that's an important lesson. Because y'all might get questions under industrial chemistry. So we'll go through the lesson, and this is the basics that you need to know to answer the essay types, so the essay type questions that they give you at the exam. Right, so you can see the topics when you take changes in matter. The very first thing they're asking you all to learn is chemical changes and then chemical equations. First, you will be learning what are the chemical changes, and um, next, what are the chemical equations related to those changes. Then the next one is reactivity of metal, how the metal reacts with different substances like um the reaction with oxygen, then water, and etc. Next, you will be looking at activity series. So first, we have to learn that in order to go with chemical equations, right? So I'll teach you all that part. And then gases, their preparation, properties, and uses. How can we prepare gas inside the lab? That means, let's say you need to get oxygen gas or nitrogen gas or whatever the gas, carbon dioxide. How can you prepare those inside the lab? How can you get those gases with different chemical reactions? So that will be taught under that topic, right? So let's move on to chemical changes. So you can see when you go to page number 86, you can see this page, changes in matter. Here, you can read the lesson. So they have given activities for y'all to read and get an understanding. Okay, so when they say a piece of magnesium ribbon, magnesium is a metal. You know that when you learnt about the periodic table, you must have learned saying magnesium is a metal. So I just wanted to highlight that part when they say magnesium ribbon. When you go to the lab, you can see magnesium ribbon is there, right? And then the main important thing of magnesium is magnesium can react with oxygen, water, and etc. Right? So it can be reacting with acid and base as well. So magnesium is over here. You all have learned before the periodic table, so that knowledge is very important. You all know that um, there is a step over here. Where's the step? I will be marking that here. All these 20 elements should be learned, and then you have to memorize and keep this table to draw in a rough paper, because they won't give you the periodic table at the exam. You need to know the 20 elements, not the very big periodic table. That is for A level. So this must be learned. And you can see here they have numbered from 1 to 20. What are those numbers? Can you all put the answers in the chat? Yes, those are atomic numbers. Right, good. So atomic number means the number of electrons around it. Or we can say the number of electrons are equal to the number of protons. You all know the protons will be inside nucleus, and then the electron will be always rotating around the energy levels, right? So always the number of protons will be equal to the number of electrons. You all have learned that before. I'm just recalling that lesson as well. So you can see from 1 to 20, you need to remember this order, right? So you can, there are several poems that you can remember according to those poems, or else somehow you need to remember this. And you all know that 1, 2, 3, 4, 5, 6, 7, 8. There are how many vertical lines? Vertical line means the lines you have from top to bottom, right? So those lines are called groups. So simply, how many groups do you have? How many groups do you have? You will be having 8 groups. Normally we name those groups in Roman numbers, right? So you can see this is the first group, this is the second group, third group, and then I'll just write it closer to this fourth group, fifth, sixth, seventh, eighth. So you should know there are 8 groups, and then the last group is named as 0 group also, right? So I'll erase this and write in front of on top of this, so it will be easy for y'all. If y'all are not sure, better to draw the periodic table to recall the knowledge, right? Okay, so there are 8 groups, and you can see there are horizontal lines. That means the rows which you have 1, 2, 3, 4. How many rows are there? So the rows will be named as periods, right? So these are groups. These are periods. How many periods you will have? 1, 2, 3, 4. 4 rows, so 4 periods, right? You should know those terms. So they might ask you questions at the exam related to this periodic table. They might give you a different letter here saying P and ask you which is this element, what are the features of this, draw the energy levels of carbon. So likewise, different questions can be asked at the exam, right? So you have to be familiar with those elements, not only the elements and the features of those, right? Because they don't ask directly, they will be asking indirectly questions from you all, right? So magnesium is over there. They are saying about 500 milliliters of dilute sulfuric acid. They're taking dilute sulfuric acid and a piece of magnesium, a few pellets of sodium hydroxide. Sodium hydroxide's also been taken. So H2SO4 is an acid. This is a base. Okay. H2SO4 is an acid, and that is a base. So what they're doing is they're trying to check what? They're trying to check if magnesium is reacting or no. Do the activities 1, 2, 3, 4 and record the observations they are asking. Okay. Why do these observations necessary? What do you all think? These observations are necessary because when they ask you questions related to observations, you must be able to write. See, the first step they do. Heat a metal spoon strongly in the Bunsen flame. Okay. And take it away from the flame. Place a mothball on it and observe. Close it with another spoon quickly. After some time, observe the inner side of the spoon. What will happen when you observe that? So first one's, can you see? First one's observation is given here, right? When you do the first practical, the observation is given below. You can see what they are saying. Mothball melted and vaporized. A white powder deposited on the inner side of the spoon, right? So when you heat the metal ball, you can see a white color substance deposited on that spoon, right? Powdery substance. So we will be learning what is that powdery substance, okay, in this lesson. So hold a piece of clean magnesium ribbon with a pair of tongs and burn it. They're asking to hold it with tongs and burn it. See what is happening. Then this will be happening. Magnesium ribbon burned with a white bright flame, leaving a white powder. Can you see even there a white powder is formed? Okay, that white powder is the oxides, right? So when you burn a metal, usually a metal will be forming an oxide, right? So that is what the powder is. Next, sodium hydroxide dissolved. The container became hot. Thermometer uh, reading rose. That means when you put the thermometer and read, you can see the temperature has gone high when sodium hydroxide dissolved. In this case, see the third one. Measure the initial temperature of dilute sulfuric acid solution. Add a few pellets of sodium hydroxide to this solution. So when you put an acid with base, so you can see this is an acid. Sulfuric is an acid commonly used in the lab. So that is H2SO4, right? And sodium hydroxide is the base, right? This is base. I'll write the formula over here. This is an acid. So you all know acid base will give you a neutral solution when it reacts together. And then what will happen? Hmm? It will be producing heat. So that's why the container has became hot, right? So simply I'll write that reaction here. Sodium hydroxide is a base which can act with H2SO4 acid. So here you must be familiar with the charges of those, right? Now sodium hydroxide is formed by what? Sodium and sodium plus ion and hydroxide ion. You know, this is a polyatomic ion. You have to learn those charges and the symbols of those ions. Those are very important. You have to memorize and keep. So sodium plus and hydroxide, okay, hydroxyl we say. If it's alone, hydroxyl combine together and form sodium hydroxide. Same way, even H2SO4. What are the two types of what ions forming H2SO4? See, hydrogen plus ion. Sodium, you can find that in periodic table. Hydrogen, you can find in periodic table. Hydrogen plus ion goes with sulfate polyatomic ion. SO4 2 minus is the symbol of sulfate. So you should be familiar with those formulas of the polyatomic ions. Otherwise, it's hard for you all to do, right? So in order to be familiar, the easiest way is when you have the periodic table, it's very easy for you all to remember the charges of these metals, right? So I'll take a different color to name those metals. These are metals. You can see I said you there's a margin here. So when you divide this from this step, the left side elements are called metals except hydrogen. Okay, so the ones I colored with blue are metals. You should know they are metals. And can you see where I divided the step? So there are two boxes over there, boron and silicon. Those are metalloids. Metalloids means they have metal and non-metal characters, both, right? So you can see the lesson where you studied periodic table. There they have given those. They have colored and given saying the orange color box is metalloids. Okay. Then the blue color box is metals. I'm showing you how can you separate those and identify. You should know clearly what are metals and non-metals, right? So when you see the left side, you can see the metals. The right side, which I have colored with pink, up to the seventh group, right? Up to the seventh group, they are non-metals. They are non-metals, and the last eighth group elements are known as what? What do you think? They're known as noble gases, right? Because they are stable gases, they don't react much with anything, right? But metals and non-metals, they can make ions and react with polyatomic ions, and metals can react with non-metals. Those types of stuffs are there related to metals and non-metals. But when you take noble gases, they don't react together, right? They are stable. So I can write noble gases. They have a stable configuration, right? So if you all want, you all can note down these stuffs. Metalloids, I think I missed a L. Should be double L, right? Metalloids. Okay. So what about hydrogen then? Hydrogen is lying on the left side, but it is a non-metal. Remember, hydrogen having mostly non-metal characters. So only hydrogen is a non-metal which lie on the left side, right? The reason they have put here hydrogen because why? To show the charges of that. So you don't want to memorize the charges of these 20 elements because you can easily get those. First group is having always 1 plus. They can produce 1 plus ions by releasing an electron. So when you check their energy level, I'll show you for an example, uh, lithium, right? Lithium is having 2 energy levels because you can see this is 1, 2, 3, 4. They have 4 periods. So always the number of periods, period is equal to the number of energy levels they have. So when I take an element in the second period, always they have 2 energy levels. So I'm drawing this for lithium. You can see lithium is number 3. If lithium is number 3, they have 3 electrons, right? So always you can see the ones who are in group 1 having 1 electron alone in the last energy level, I mean the outer energy level. So they are always, they will be willing to release an electron outside and form +1 ion. Same way when you see group 2 elements, when you draw the electronic configuration and see, or when you draw the electrons on their energy levels, you will be able to see that they are having always 2 extra electrons outside. They always like to release those 2 electrons and form 2 plus ions. Even third group is the same. They like to release 3 electrons and form 3 plus ions. Fourth group also releases electrons and they have 4 electrons in the outer shell, right? So they used to release those electrons and then form 4 plus ions. But after fourth group, that never happened. Okay. After fourth group, they don't want to release their electrons. They always try to grab electrons because nitrogen phosphorus having 5 electrons in their outer shell. For an example, when I draw nitrogen, I'm drawing the uh, planetary model of nitrogen. You can see. So nitrogen is having 7 electrons because the number in periodic table is 7. So atomic number is 7. So 1, 2. 2 is gone for the inner shell. And then how many will you have for the outer shell? You have 5 electrons in the outer shell. So since the number of electrons are really high, they don't want to release those electrons. Nitrogen will be willing to get electrons to become stables. Now they have released electrons to become stable. Stable means they want to keep only what? Energy levels with full of electrons. They don't want to keep empty energy levels. So what nitrogen does is nitrogen will be taking 3 electrons. So because of that, when they take electrons, you know, the charge of electron is minus. So they will form 3 minus ions. Same way, oxygen is having 6 electrons in the outer shell. So they take 2 to become stable. So the negativity is really high. So they form 2 minus ions. And then this one 1 minus ion. They don't react. Noble gases are stable, so they don't have a charge. So this is how the charges will be for these relevant groups, right? So always when they ask about sodium, when you see sodium somewhere in a reaction, always sodium will be forming 1 plus ion. That means just you can mention as plus. When you take aluminium, aluminium is forming 3 plus ions. When you take oxygen, oxygen will be always forming 2 minus ions. And then chlorine, 1 minus ion. So likewise, when they are forming the ions, this is how the order of the charges will be. right? So if you know the periodic table, you can mark those ions that they are forming below the periodic table in a rough paper and keep it with you when you're writing reactions. Those are important. But polyatomic ions are not mentioned in the periodic table, so you have to learn the table separately for polyatomic ions. I think you all know where it is. You can search where it is mentioned in your book in the same lesson where you all learned about periodic table, right? You all can see that one. I'll show you just the basic polyatomic ions that you need to remember. Okay, look at this table. You don't want to remember everything for O levels. The important stuffs you should learn is ammonium, nitrite, nitrate. So you should know when they say nitrate, it is NO3 minus, right? When they say sulfate, it is SO4 2 minus. So sulfite is not much mentioned in O levels. So I'm giving the important ones for all. Hydroxide is important. You should know that it is OH minus. Phosphate, PO4 3 minus. Carbonate is important. So the important ones are given in your textbook. You can see. These are not much necessary. Permanganate is important. MnO4 minus. And yes, chromate CrO4 2 minus is important. Okay, other than that, the other polyatomic ions are not much important during O levels, but you have to learn these stuffs which I have circled. Okay, right. And let's move on to the reaction then. So as I told you, if not magnesium, they have given sodium hydroxide, right? Sodium hydroxide base reacts with H2SO4 acid. First, you need to write down the ions which are present in those substances, right? So H plus goes with SO4 2 minus, then forming H2SO4. You all know that this 2 uh, is down from sulfate. Okay. How did this 2 come? That is from that sulfate group. Right, so first you have to write down the 4 types of ions which is present, sodium hydroxide, and then hydrogen sulfate forming H2SO4. So what happen is they exchange their partners. Sodium plus will be taking sulfate as the partner, right? So hydrogen plus will be taking hydroxide as a partner. So they exchange their partners. Sodium goes with sulfate. So you all know sodium is plus. Sodium can form plus ions. Sulfate is 2 minus. So you must have learned that to write the what chemical formulas of those. You have already learned those. So what we do is when you have two ions, we just check if we can cancel the same numbers on top when we have for the charges. But if there is nothing to cancel, this has plus, this has 2 minus, you have to flick those numbers below the ion. So sodium will become 2. How did this 2 come? That was the 2 which was on top of sulfate. You need not want to put the charges. It's not necessary to put the charges, but you can take the 2 down and say sulfate. There is nothing to take down because this is 1 plus. Okay. So no number below sulfate. SO4 will be just written, and then you have to write number 2 below sodium. So this is a product which is formed sodium sulfate and plus, so this is a salt actually. A base reacts with acid and form a salt plus, if you have H plus and OH, so it's like O and H is hydroxide and H plus. What happens is this will come and combine with the hydroxyl ion, and then it will be forming water molecule, right? So H2O will be formed, right? So you all know that in a neutralization reaction, um, we will be getting a salt and water as the products, right? So now after deciding the products, so the products should be decided by writing the chemical formulas separately. So you have to consider about the charges of those ions and then only write the product. Write down the product. Still, we haven't balanced the equation. So after deciding the right product, the next step is to balance the equation. So in order to balance the equation, see sodium is 2 and then you have to make this 2. So when you make sodium 2, you can see um, oxygen and hydrogen is also becoming 2. So you need to check if you have 2 oxygens this side. Uh, let's check the total. So you have 2 oxygens here, and then I'm not thinking about these oxygens because already here there is a sulfate group, I mean SO4, and here also SO4. So since those two are balanced, I'm not thinking about that. I'm thinking about this oxygen. 2 oxygens are here, so I'm making that oxygen 2 over here. Now let's check if we have 4 hydrogens, because this hydrogen became 4. 2 times 2 is 4. You can see here there are 2 hydrogens, and then here there are another 2 hydrogens. So the reaction is balanced once you add 2 to this water molecule. So this is the balanced reaction for this acid-base reaction. So whatever the chemical changes you observe in the lab can be written as a reaction. That is what we are learning in this lesson, right? So if you have an important note, if you like, you can note down this in your writing book and show the chemical reaction. You might get a question. And for these stuffs also we can write reactions even for the first one, second one. I'm not explaining you now until I teach you all the activity series to get a proper idea. So simply I explain this because this should be remembered before everything. That is the basic reaction that you all would have studied in previous grades as well. So we used to say this is neutralization. Neutralization means what? An acid. If an acid is reacting with a base, yes, so we used to call that is neutralization reaction. Okay, we'll go with the fourth one. Put a piece of magnesium ribbon to a beaker containing dilute sulfuric acid. So here they are showing how a metal can be reacted with an acid, right? So basically, you will be learning 4 parts in this lesson. A metal, when we take a metal, how does it react with oxygen? How does it react with water? Then how does it react with acid, and how it reacts with base? So for all of these, you first need to know about the activity series, right? So we are not considering about the equations now until we study the activity series first, right? So now you can see when you take reactions, there are physical changes and chemical changes. So physical changes can be observed, right? What type of changes will be physical? Can you all put down the answers in the chat? Let's see. Yeah. So physical changes means the changes which you can observe, right? So let's say if a solid is melting, so that is a physical change. Or when you see uh, what a liquid is releasing gas, you can see there the state is changing. So simply when the state is changing, those are physical changes which you can observe. Chemical changes means when one substance reduces and a new substance form, right? Those are known as chemical changes. That means one type of substance will be reduced and a new substance will be formed in a reaction. Like we saw the acid-base reaction. You also sodium hydroxide goes with sulfuric acid, but the products are different, not the same thing. So those type of reactions are called chemical reactions because they're chemically changed. The substance is fully changed. So when you burn a wood, you can see the um, structure is fully changed because there is a chemical reaction over there. But when you take physical reactions, the substance won't be chemically changing. You can see only there are changes in states, right? States means what are the states that you know? Mention the states to see. Yes, solid, liquid, gas, changes between those, right? So they might ask you to underline examples for physical changes. So remember those examples and examples for chemical changes. They might ask you to underline at the exam. So burning of firewood, heating limestone, heating potassium permanganate, those are things that will be changing chemically. That means you will be observing that new products are formed in those types of changes, right? So whatever the parts I highlight on the screen can be written in your book because those are important points. So you can pause the video and write those. Next one is what are chemical changes? We don't have much to learn about physical changes. You all know what are physical changes and it's understandable. But chemical changes should be learned because we need those to write the equations, right? So the very first thing you can see when we are writing a chemical reaction is an arrow in between. You will see an arrow. So on the left side of the arrow, always the reactants will be written, and on the right side of the arrow, the products will be written like we wrote now. I just showed you an equation. So reactants and products are two main things that you can see in a chemical reaction. Right. So next one is they have given a table for y'all. Nature of the reactants, observations, nature of the products. Okay, just to see what are the things that you're adding and what are the products that you're getting. So this will be done in your school lab to see whether they are giving different products or not. I mean, the products will be fully different, not same as the reactants. So that's why they are asking to fill this table to get that idea. And they are directly moving all on to chemical combination reactions. You can see that magnesium reacting with oxygen, they have given, then carbon reacting with oxygen. They have shown you the types of reactions in chemistry, right? So remember, I'll just, before going to activity series, I'll just tell you the types of reactions we can have in chemistry. Okay. So according to the nature of chemical change, right? According to the substances which is forming, chemical reactions can be divided into 4 groups. See, the first one is chemical combination reaction. Combination means 2 reactants will be combined and give you a product. For an example, they have shown here, magnesium is combining with oxygen. Can you see? Both the elements, I mean, both the ions are combined, right? Carbon is combining with oxygen. Both the ions are combined, right? So don't worry, I'll teach you all how did this reaction come. You must be wondering, Mg and O2 is somewhat totally different, and how did it become MgO? I'll explain that to you all. So first you should remember is chemical combination reactions, right? The next one is chemical decomposition reaction. Decomposition means they decompose, they separate the reactant. See here, potassium permanganate is a reactant. It can be, when you heat it, it will be separated into potassium manganate. and manganese dioxide and oxygen. Don't worry how these products came. You must be thinking, how did these products come? How can we decide those products? So don't worry about that. We have to do the reaction in the lab and remember those products for this particular reaction, right? And then you can see calcium carbonate can be decomposed into two chemical products, right? So just remember the next category is you will have a reactant that can be divided into 2 or 3 products. Next one is single displacement reactions. That means in this reaction, now when you have zinc and copper sulfate together, what zinc does is, see, zinc will be picking sulfate as the partner and kicking out the copper, right? So see, can you see zinc sulfate has been formed and copper is alone. So when one reactant can move a substance out of the other reactant, we call it as single displacement. It can kick out only one substance out of this. So the reaction is written below. You can see here, see zinc. It will be picking not copper. It will be picking sulfate as the partner. Out of this copper sulfate, only sulfate as the partner, and copper is alone over here. So when it is kicking out one substance out, right, we call it as single displacement reaction, right? You can see another example, KBr reacting with chlorine gas, and then it goes with chlorine, K goes with Cl, Br2 is alone. Now you must be wondering, why do we take Cl2 for oxygen O2? Because the gases are present as a molecule in nature. Okay, for an example, when you take nonmetals, I'll show you what are the gases present, what are the nonmetals present as a gas. So when you take these nonmetals, let me take this periodic table to make it easy for you all. Here I can circle and show you nitrogen, oxygen, fluorine, chlorine, those are nonmetals, and they always present as N2, right? O2. Then what else? N2, O2, F2, Cl2, because they are gases, right? So when you're writing reactions, you will see they are mostly, they will be always present as gas. Cl2, oxygen is also O2 because they are present as a molecule in nature. Oxygen won't be alone in nature. Always it's a molecule. So two oxygens bonded together. Two nitrogens bonded together. I hope you all have studied that as well. Oxygen is having a double bond. So they might ask you at the exam a double bonded molecule, which is a nonmetal. Oxygen. Nitrogen is triple bonded. Okay. Why do we say double bond? Because this has 2 electrons in between when they form a molecule. I mean, they have 4 electrons which will be forming what do you call double bond. That means the electrons of these two oxygens will be combined with the electrons of the other oxygen. Same way in nitrogen also. When you see the chemical bonding lesson, you can get an idea about those. Right. So just an idea. So you should know what are the types of chemical reactions. So you know what is what single displacement and what is double displacement. Double displacement means when you go to double displacement, look at this. Each reactant will be changing their partners. Now, when you see Fe, here see, Fe will be going with hydroxide, and then sodium will be selecting sulfate as the partner. If they are exchanging their partners, when Fe selects OH as the partner, sodium goes with sulfate. So those kind of reactions are known as double displacement reactions. So you will have two reactants, and then calcium selects carbonate as the partner, sodium selects chlorine as the partner. Right? So those types of reactions are known as what? Double displacement reactions. Right? Just remember those reactions also. Right? Here the important part is to know how to write down these reactions. Okay, so you can see carbon is not a gas. It will be present as a solid. So that's why they have taken C. Oxygen is a gas. So naturally it's present, it is present as a molecule. So they have taken O2. So when you do this chemical reaction and check, you will observe that it produces carbon dioxide as the product. That's why we have taken CO2 here. So nothing to balance in this reaction, I mean in this equation. But some equations are there. When you take hydrogen and chlorine and make it combine together, it will be forming HCl acid. Okay, HCl is an acid, same like H2SO4. Sulfuric is a common acid used in lab. Same as that, HCl is also a common acid used in lab. So when they ask about acid, remember those two. HCl can be produced by hydrogen and chlorine. So this is simply happening in industries. They can use these two gases to form HCl. So why did we put 2 in front is because now first thing we know what are the reactants and what are the products. The next thing we have to do is, after knowing what are the products, we have to check if the reaction is balanced. That's why we put a 2 in front, since we have 2 hydrogens and 2 chlorines here, right? Next one is chemical decomposition reactions. You can see KMnO4, right? That means potassium permanganate. When you take that substance and then you all know what is potassium permanganate. We used to say condis also in general term. So you can take that, it's a purple color substance. When you heat it, there are products formed like potassium manganate, manganese dioxide, and oxygen. When you heat it, you will see this color, what changes. Purple color will be changing into like dark greenish black color substance. Okay, so that is the product for potassium manganate. You should remember this what formula also. K2MnO4 is potassium manganate. KMnO4 is potassium permanganate. Can you see what are the ions present here? Potassium plus and permanganate. When I taught you polyatomic ions, I told we have to remember potassium, the permanganate's formula, MnO4 2 minus. Manganate is having a formula of MnO4 minus. Okay, check if you all have included in your table. If you all are not sure with polyatomic ions, better go back and then note down the table first, right? So what does potassium do is, here see, it was permanganate over here, right? Here, the permanganate will become manganate. 2 minus will become minus, and there's another product form, MnO2. You should remember these products, right? K2MnO4 is forming, then MnO2 is forming, and when you do this reaction, you will observe a gas is being released. It's bubbling out. So that is oxygen, right? So you should know there are 3 products forming. After learning those products, check if the reaction is balanced. So you can see here it is K2. two potassiums are there, but here only one potassium is here. So that is why we put a 2 in front. Then when you put that 2, you can see Mn has become 2, right? When manganese become 2, this side also there should be 2 Mns. Here one is there and here another one is there. So that is fine. When you check the number of oxygens, here you have 8 oxygens. So you need to check if you have 8 here, 4 here, and 2 here, 2 here. So altogether there are 8 oxygens. So when you put a 2 in front, automatically this reaction will be balanced. Okay, so that's how you have to remember these reactions. I will be mentioning some reactions as important. So because those can be asked with a practical. They might say they're taking a purple color substance, or they might say they're taking potassium manganate and heating it. So there are few products formed. They might give you the colors and say to write the reaction. Then you must be familiar that this is the reaction for that scenario. They might give you all a story, a scenario, and ask you to write the reaction, right? Or they might ask you, mention a reaction which can produce oxygen. So can you see? We can do this reaction in the lab and get oxygen. What? Stored separately. Let me show you a picture of that. When you see the how they are, look at this. You can see all the equipments are placed accordingly. This is how they use the equipments to produce oxygen, right? Look at the objects. They will be keeping the Bunsen burner here, add potassium manganate over here, and they will start heating it. When they heat potassium, right, so this is how the apparatus will be. You can see they have put potassium permanganate over here. They will start heating. Then what will happen is you will see the color of this is changing, right? It won't be the usual color like I told you. While this is changing, you will see that there is a gas formed in this test tube. So that is the oxygen gas, right? That is the reaction for this. So you need to remember that it's an important reaction. And they might ask you to write this reaction and ask you what type of reaction it is. So you have to mention that it's a chemical decomposition reaction. So they might ask you those type of questions, right? And the next thing is you all should know under decomposition reaction, an important thing is this calcium carbonate forming calcium oxide and what? Carbon dioxide. When you take calcium carbonate and heat it, what will happen is these are the two products formed by that one. Okay. Let me check if that is available, if they have given an apparatus so you can get a proper idea of that. Look at this. So heating calcium carbonate, they have just given the reaction. Okay. So you can see calcium carbonate is a solid substance. Then when you heat it, it will become powdery. So that is calcium oxide, and you will see a gas is being released, which is carbon dioxide. So how can we identify whether it's releasing carbon dioxide gas? Do you have any idea to check how can we release it? How can we find it? So what can you do? So what can you do is you can use a tube and send out that gas through lime water. You will see that the lime water is becoming turbid. right? When you release carbon dioxide, turbid means it will change into milky color. The clear lime water will be changed into milky color. So that is to identify carbon dioxide. How can we identify oxygen? Now let's say a reaction has happened. You need to know whether it has released oxygen, or they might say you that this happened and ask you which gas it is. So how can we identify oxygen? You can put the answers in the chat. Yes, exactly. So I can see the answers very good. So you can see that I have shown you a picture as well. So what can you do is you can take a glowing splint. Now let's say this is the test tube that you got oxygen stored in the previous practical. I mean the previous apparatus which we learned. What you have to do, take that test tube and bring closer the glowing splint. Then you will see the glowing splint is burning very well inside. It will give you a good flame if it is oxygen gas. But same thing, when you take a glowing splint closer to carbon dioxide gas, will that happen? Will the flame become higher, or what will happen? No, the splint won't be giving a flame. Now, let's say you had a flame, even that flame will be gone, right? It won't be there. So that's how we separate and identify the gases. And then this reaction is also important. You can see a reactant has been divided into two, into water and oxygen. So hydrogen peroxide is a what do you call, chemical which you have in the lab. It's a white color liquid type of what? It's a white color liquid actually stored in amber color bottle, a brown color bottle. When you go to the lab, you can see. But why do they store that in amber color bottle? Because it's reactivity, right? It is very reactive with oxygen and what do you call, sunlight. So because of that, they have used the brown color bottle. Let's say you open it and keep it in sunlight, or you just open the bottle and keep. What will happen is hydrogen peroxide will be quickly decomposed into water and oxygen, right? And there is no use of that solution then if it be decomposed. Same thing when you take hydrogen peroxide and heat also, the same thing will happen, right? So I'm giving stories for you all to remember those equations. So after deciding the products, you know the chemical formula of water, chemical formula of oxygen, you have to check if the reaction is balanced. If it's not balanced, we have to try balancing it. So how can we try balancing it? Let me write down. Let's say they have given a scenario saying hydrogen peroxide was there in a bottle, and it has been heated or it has been opened or something, and they're asking you all to write the reaction for that. So you should know it will be decomposed into water and oxygen. Then how to balance it? Where to start? You must be wondering. You can see oxygens. When you take oxygens, um, it is not balanced. When you consider hydrogen, you can see here hydrogen 2 and here also 2, but oxygens are not balanced. In that case, you have to put 2 in front to make this an even number. Now let's say you put 2 here. It's not balanced yet. Still you're getting 5 oxygens. So we cannot make this 2 as 5. For that, we have to put 2 over here. Now you can see the number of oxygens is an even number. You have 4 oxygens. So 2 can be made as 4 by putting a number 2 in front. Now you can see there are 4 oxygens and 4 hydrogens, and the equation is balanced. Why do they give a triangle? If you see a triangle on top of an equation, that means that equation is being done by heating. Heat is being produced in that reaction, right? Okay, so I hope you all understood that reaction also. And silver oxide. Look at silver oxide. That can be decomposed. When you heat silver oxide, it can be separated as silver and oxygen. So those are the reactions under chemical decomposition reaction. Okay. Single displacement, it's very easy for all, exchanging the partners. And then now see, for an example, when I take magnesium goes with chlorine, how will you decide whether it's MgCl2? You must be wondering, how did MgCl2 comes? You have to check what are the two ions. Magnesium goes with what? Magnesium plus, I'll write it properly. Magnesium plus goes with chlorine. Okay. So chlorine is present as a molecule in nature, but here when you're deciding the products, you have to see what are the two types of ions. Mg plus ion goes with Cl minus ion, right? But Mg is not plus. Why is that? Tell me to see. Yes, I can see few answers in the chat. It's not plus. I wanted that answer from you all. Why is it not plus? Because Mg is in second group in periodic table. So it should be 2 plus, right? So what happens is, we all know to write formula. Always we have to exchange the charges when we are writing the formula. So MgCl2. Here the number is 1, so nothing to move below Mg. But when you take this 2 below chlorine, it will be MgCl2. So MgCl2 is a product. What is the rest? What is remaining when you see the HCl? H is the remaining one. So when you're writing the reaction, this is how you will have your beginning reaction. Mg with HCl acid. What happens? You have to decide. So you know the product is MgCl2. Then you can see hydrogen is remaining means, only hydrogen is remaining means obviously it's going to be hydrogen gas. Gas we can show with an arrow like this because it is being released, right? After deciding the products, then you have to start balancing. Here there are two chlorines, but here there is only one, so you can put 2 in front. Then you can see hydrogen gas has 2 hydrogen, and here also 2 hydrogen, 1 Mg with 1 Mg. The reaction is balanced. That is how they have got this reaction. So don't look at this reaction and write. See what are the two reactants first. Then decide the products. Okay. After deciding the products, balancing part will be the last part of your what? Reaction writing. Okay. When you're writing a reaction, that will be the last step to do. Balancing is the last step. So those type of reactions are known as what? Single displacement reactions. There are several reactions. Don't worry, we will be studying detail. We will be studying in detail, but even make sure to remember examples for those reactions. They might ask you 1 or 2 examples to write. Double displacement, you all know they exchange their partners. I'll just take one example and show you how did this reaction come. So ferrous sulfate is a substance. Then you can have ferrous sulfate, right? And then it goes with what? Since there are letters, I'll just make it clear and then write it. Let me draw a box first. Okay. Give me a second. Okay, look at this. So ferrous sulfate, I'll write on top of this. Ferrous sulfate is a substance that what we can do with ferrous sulfate. We can make it reacts with, let me say NaOH. That's a base. What will be the product? They might ask you. So you don't want to worry. You can see ferrous goes with sulfate. So it formed ferrous sulfate. And then sodium goes with hydroxyl. It has formed sodium hydroxide. So ferrous simply goes with OH. So it will be FeOH. How will you decide the charges of this? Remember, Fe has a charge of 2 plus and 3 plus. So the common charge of Fe is 2 plus. We will be studying under activity series. So the common charge of Fe is 2 plus. When the rusting occurs only, Fe3 plus will be formed. Otherwise, usually Fe3 plus won't be forming. Right? So you have to know that the charge of Fe will be 2. So that 2 is being brought below this. That 2 is belonging to O and H both, because hydroxyl is OH minus. So that minus, when we take it below Fe, nothing will be written because we don't write 1. And the next product is sodium sulfate. You have to balance this now. Sodium is plus, so nothing to bring below sulfate. Sulfate is 2 minus, so we have to make sure to write that 2 here. After deciding the products, you have to check if the equation is balanced. Sodium 2, here it's only 1 yet. So just put 2. And then you can see here Fe is 1, Fe is 1, OH, you see we have 2 OH because 2 is in front. Here also we have 2 OH. This you have to write the 2 properly outside the bracket. Otherwise, you will be wondering it's belonging to what? You will be wondering it is belonging to H only. Right? So you have to write the 2 properly outside the bracket. Sodium 2, sulfate 1, sulfate 1. Yes, all are balanced. So this is how this reaction came. So this type of reactions we say double displacement reactions. So what you have to do when you are writing your note, put the topic, write both the examples. Don't go to copy this and write. First write the product, then write the reactants, write the products, check if you can balance those. That's how you have to prepare your note. Okay, I hope it's clear. Then the next part is this. Chemical equations. Then they have started writing chemical equations. Magnesium reacting with oxygen. How does magnesium react with oxygen? Then aluminium with HCl. So a metal with an acid. Magnesium reacts with oxygen means a metal with oxygen. How does it reacts? Okay, they are showing you several reactions. Then a metal, an oxide with carbon monoxide. How does it react? How does it react? Reactivity of metals. Reaction of metals with air. Can you see? Air means what? Simply, how do they react with oxygen? Then a metal reacts with water. How does it react with water? Okay, they have given. So before everything, I would like to teach you all what is an activity series first, before everything, right? So after knowing the 4 types of chemical equations, you need to put the topic activity series, right? So quickly put the topic, and I would like you all to draw this on your book after putting the topic. What you have to do is, this is how you have to draw. You have to separate according to their reactivity. Activity series means we will have this board in industries also, where we produce metals. Usually they will have this activity series put on a board because they need to check the reactivity of those elements always. So this is very important when you learn about industrial chemistry. So here you will be learning the series obtained by the arrangement of metal in the descending order of their reactivity. Why do they say descending order? Because the most reactive elements will be on top, right? So when you go below this, what about the reactivity? The reactivity decreases. Reactivity decreases. Okay. So when they ask you the most reactive element, you should be able to say potassium. The least reactive element is aurum. Aurum means gold. Okay. So we'll rearrange those according to their reactivity in this way. Okay. So why do we use activity series? Why do you think that we need an activity series? Just to know the reactivity and stay? No, the reason we learn activity series is, just drop your answers, we'll see. Yes, I can see there are several um, reasons mentioned. Very good. So you can see the reasons below as well here. So activity series is used to find the method that prevent corrosion of metal. That means, let's say you have a metal substance, you need that to prevent from corrosion. You have to decide to cover it with another type of metal. So it should be covered with a high reactivity metal. Let's say we have Fe here. You can see. So if you need to avoid the corrosion of iron, Fe means iron, you have to cover that with a magnesium tape or zinc paper or somewhat. It should be a metal on top of this. A high reactivity metal can prevent corrosion of iron. Okay, so in that way, to decide which metal to use, activity series is important. Next one, help select metals to make electrochemical cells. What type of metals I should decide for electrochemical cells? So that it is important. You know, electrochemical cells should have two metals which is different in reactivity. So for that we need activity series. Next thing is, activity series can be used to decide the method suitable for extracting metals. How to extract, how to separate those metals. You know, metals are present as stones and mountains in nature, which it is mixed with the stone, soil, and mountain. Uh, it is mixed with the soil and different chemicals together and present as mountains, right? So how to extract those out of those stones? We have to decide that first, right? So for that, to decide the extracting method, we need to know the reactivity. Okay, and reactive metals such as sodium, potassium cannot be seen as a native metal in natural element. Native means they don't be present alone in natural environment. Like I told you, they are present as a compound with stone, soil, they are mixed together. So in order to decide in which method to extract, in which method to separate it, activity series is important, right? The metals of moderate reactivity such as Fe, Sn, zinc, lead are extracted by reducing their compounds by other elements or compound. So they use another element or compound to separate this one. Another element or compound means they use another substance and then separate this. Okay, we will be learning what is reducing means. The metal of low reactivity such as silver, gold, and platinum occur in nature as native metals. Native means they are present alone. They are not compounds. They are not mixed with other compounds, right? But the high reactivity ones don't live alone. Can you see? They don't stay alone. They are mixed with other compounds. So for that, we have to use electrolysis. That means what do? We give current and then separate it. Okay, or there are methods that we have to use to separate it. Electrolysis means we have to use a current and separate it. Just heating is not enough to separate those. We will be studying properly what is electrolysis means. Okay, so in that, electrolysis of their fused molten chloride to be discussed in grade 11. You will have that process properly to learn in grade 11. So this is the basic of your lesson. Now you will be wondering like, there are different methods to separate these elements. Where's the margin of this? I want you all to write these three first and leave a space and write magnesium. Then aluminium, zinc, Fe, S, and Pb will be coming into one group, and these ones, I can start from, yeah, these three will be going into another group, right? This is how it will be. But here the separation should go up to this and this. Usually, when we take the first three elements, how do we separate those? What do you all think? We use electrolysis method to separate those, right? So the second column which I have marked here is being separated by reducing, and the third column, can you see the third three elements that I have selected is being separated? They are native, so just by heating we can separate those. So this is how the separation works. So always the first few elements should be separated by electrolysis and their reactivity is really high, and you should know the charges of these. Potassium is +1, sodium is +1, calcium +2, magnesium +2, aluminium +3, zinc +2, ferrous usually +2. Only when it's corrosion, it's +3. So I'll just put +2, +3 both. Then zinc +2, lead +2, copper. Copper has two types of ion, +2 or +1. Both are there. Ag mostly +1, Ag +1, platinum +1, +1. This is how their charges will be when they are reacting with oxygen or any other substances. So make sure to remember their charges first before everything. So I want you all to draw the activity series first by leaving space wherever necessary. I will show you where you have to leave one line as a space, and make sure to draw this in the middle of a page because we will have notes to write in the corners. So make sure to write it in the middle and leave spaces wherever I have drawn the lines, right? Wait, I will draw the lines for you all. Leave a space over here because magnesium having a special reactivity with water. So I have to explain those, and better leave a space over here. And this order should be memorized. You have to memorize this order. Then only it's easy for us to write the reactions. Right. And I hope you all understood up to this part. Um, Writing the reactions will be discussed next week. So I'm wrapping up the lesson for today. Right. Then see you again next week.